All right, calculus folk. I also wanted to go through activity 3.3.2 with you because, again, I felt in class today it was very, very rushed. There's a lot of good stuff happening in this problem, especially with the calculator, that I don't want you to miss. So let's go through activity 3.3.2. We'll start with part A, where it says find all the critical numbers of G. All right, so the critical numbers are going to be where G prime is equal to 0. So G prime is going to be 1/3 times 3, so that's 1 x squared minus 2. I take that x squared minus 2, set it equal to 0. I get x squared equals 2. Take the square root, and I get x equals plus or minus the square root of 2. Now, you could have done this on your calculator as well. Either way, if you just throw this into your calculator, x squared, not the equals 0 part, but x squared minus 2, see where it's crossing the x-axis, you're going to get plus or minus 1.414. So I'm going to say this is approximately equal to plus or minus 1.414. Now it says using a graph and utility for part B, construct a graph of G on the interval from -2 to 3. Okay, so notice how they put a fraction here, 1/3. I just want to review with you how to do fractions on your calculator. It's been a while since we've done that, but if you hit, what is it? I guess it's alpha y equals, then you're going to see the ND, numerator denominator, show up. So we can type in 1/3. We're going to put our x cubed minus 2x plus 2. And I start with a zoom 6. And so there's a sketch of the function right there. But it says, okay, so now we've sketched the graph. Part C says, from the graph, determine the x values at which the absolute minimum and absolute maximum of G occur on the interval from -2 to 3. So what we know is that, now, we could just find a max or min. All right, we got that, and I don't want to make this problem overly complicated, but I think there's something else that we've talked about, and that is the fact that we know a max or min can only occur at these critical values, 1.414. All right. Furthermore, it gives us this interval from -2 to 3. So when I go back to my calculator, the first thing I'm going to do is I'm going to set my window from -2 to 3. And I can have it count by ones. And so there's the graph. Okay. Now, I want to show you what's called a candidate test. This is a table of values. Again, I can just calculate a max and I can calculate a min. And I don't want to overcomplicate this problem. But if we go to our table of values, right now our table of values is just programmed to, keep giving us different numbers, and it's giving me fractions. You might get decimals, but I'm getting fractions. But I want to specifically test it for a couple different values. So I'm going to go second window, and I'm going to change the independent variable, which is x in this case. I'm going to change that to ask. And so now when I go back to my table, it says, okay, what do you want x to be? Well, I need to test the endpoint. So one of the endpoints is -2. Then I got my critical numbers, -1.414. I'm going to round or truncate to 3 decimal places. I got +1.414. And then, of course, I got 3. All right, so these are the only places where I can have, what were they asking for? I can have an absolute min or an absolute max. I have to test the endpoints because as we look at this graph, there is a chance that that endpoint right there, right at -2 or right at +3, that could be higher than all the other points. And we see from the graph that 3 is the highest value. Well, our table supports that. All right, I got 10/3, which is 3 1/3. I got 3.8, I got 0.11, and then I got 5. So I know from part C, it says where's the absolute min and the absolute max? Well, the absolute max is going to happen at x equals 3. And the absolute min is going to happen at x equals 1.414. So I'm going to go ahead and answer that question. And this word absolute, this is we've introduced you to this new word absolute, and the absolute is used when we have this closed interval. We're no longer talking about an entire domain. Because if we were to look at this graph on entire domain, there is no min or max, global min or max, right? But on a closed interval, there is. So I can say f of x has an absolute max at x equals 3. We can't call it a global max because global is reserved for an entire domain, negative infinity to infinity. So we're going to call it an absolute max. And f of x has an absolute min at 1.414. Now things get interesting because now the author of the book, Matt Bolkin, says, well, how do your answers change if we consider the interval -2 to 2? So let's go back to our calculator and our table of values. We're no longer going -2 to 3. We're only going -2 to 2. Well, look at that. Now, at x equals 2, this output is only 2/3. So now the maximum occurs at -1.414. Let's just show this on the graph so you can see what I'm talking about. If I change the x max to a 2, we can see that now the maximum function is occurring here at -1.414. The minimum is still occurring at positive 1.414, but we have a new max, all right? And our table supports that the new max occurs at -1.414. I'm not going to write that answer down, but you can see what just happened there. And then the final question is, what if we consider the interval -2 to 1? Now what happens? So we're going to go back to my calculator. We're going to go to the table of values. Instead of a 2, we're going to make this a 1. It now has an endpoint of 1, and that's at 1/3. So now where's the max? The max is still at -1.414. Where's the min? Well, let's see. I guess the minimum, 1/3 to 0.11, I think positive 1.414 still gets a minimum. We can go to the window, change this to a 1, graph it. Now we're going -2 to 1, so we can see that there is a minimum. Oh, you know what? I screwed that up. Let's go back to my table for a second. Because 1.414 is actually greater than 1. So I need to get rid of that now. That's no longer in the, this is no longer part of the domain, because again, positive 1.414 is greater than 1. So I didn't realize that till I looked at my graph, right? So now we can see there's a max at 1.414, but the minimum, I should say absolute max, the absolute min is at positive 1. So what's the point of this activity? The point of the activity is that as you change these intervals, you have to test the endpoints. Not only do you have to test the critical numbers, but you have to test the endpoints as well to see where that max or min occurs. And that's the whole point of this activity. It's really not too hard, but it's a great exercise in using your calculator to its fullest potential.